Number 7 from paper 1 of the 2018 Higher Maths. 8 marks this time. Here we go. We've got a curve and we've got a line intersecting it. Looks as if it's a tangent at the point P. It gives you the equation of the curve and it says write down the coordinates of P, so it's just ignoring this line just now. The coordinates of P where this curve crosses the y-axis, and it just says write down so you can just state it. But normally you would say this. If you're on the y-axis, that means the x coordinate is 0. And putting x is 0 into that gives the answer 5. So it's the point 0, 5. There's a mark. That was easy enough. 2. Now, here's this line. What's the equation of the tangent for 3 marks? The tangent to the curve at P. Well, it's a line. You need 2 things. A point on it. Well, I've got the point, 0, 5. I need its gradient. We'll get the gradient of the curve at that point. So you'll need to differentiate it. So dy by dx will be multiply by the power, take 1 off the power. 2 times 3 is 6, multiply by the power takes 1 off the power. And if it's a linear term, then it's just the coefficient 2. So it should be 3x squared minus 6x plus 2. That's what the gradient is, which means at this point, when x is 0, you put 0 into it, which means that the gradient's going to be, well, 0 is going to be 2, isn't it? I'll just put it in. 3 times 0 squared minus 6 times 0 plus 2, so the gradient is 2. Put it all together for the tangent. Y minus the y coordinate is the gradient times x minus the x coordinate. So it's quite a neat little line. Y equals 2x, there isn't anything there, plus 5. Now I don't know why I did that, because I could have stated that straight away, since you know where it cuts the y-axis. Just wasn't thinking. You know, its gradient's 2, it cuts the y-axis at 5, so immediately y equals 2x plus 5. Those, I reckon, are the 3 marks for that part. There's the first mark there. Now, find the coordinates of Q where this tangent meets the curve again. So where's Q? Well, that just means substitute the line into the other one. So x cubed minus 3x squared plus 2x plus 5 should equal 2x plus 5 at the points of intersection. So there must be a mark for equating them. Bring it, look at this, bring it over to one side. X cubed minus 3x squared just equals 0. Those terms cancelling out. Now that makes that extremely easy to factorise. It's got a common factor of x squared, leaving x minus 3, which means you've got x equals 0 as a double root, and that's right, that was the tangent point, and x equals 3 as the sole one, the clean cut. So that means at Q, x equals 3. Now find the y coordinate, just use the simple equation for this. So if x equals 3, that means y would be 2 times 3 plus 5. 6 and 5 is 11. So Q is the point 3, 11. Not sure where the 4 marks would be. There must be 1 mark for equating them, 1 mark for reducing them and factorising, or maybe it's 1 each of them, and then a mark for x, a mark for y. Maybe you had to state what x was. Maybe we should play safe and state why x is 3. X is 3 because you know at Q, x is not equal to 0. Probably wouldn't have needed to do that. Simply picking out the 3 would have done.